Hello and welcome to my channel. I am Professor Dr. Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. I'm here today with my molecular models, right? So I thought I must show you how to make few of the bondings and how you are going to make some of the very important compounds which we normally make again and again and repeatedly we have to make. So you should be familiar of how you can use these models and how you can make them. I have uploaded another video also in which I have shown how you are going to connect all these with the help of these connecting bonds. Today again I'm going to make some models, some common examples like I'm going to tell you now, some straight chains, then the cyclic ones of course, so that you will be familiar with with all the ways how to build these models, these structures, and you will be able to see how we connect different bonds. It is basically to show you the connectivities, different connectivities, how you can connect the molecules, as I have shown in one of my videos. This triple bonded nitrogen atom, right? The two nitrogen atoms that are bonded together with the help of via this three triple bonds, the strongest bond, right? So in the same sense, I'm going to make you understand and make you learn how you can make different molecular models and how they look like when you actually you are looking towards the molecule. How does it look like? So this is very important to note, because up till now we have been only using these models, or using, we were studying in the books and we used to see on different pages how the structures are drawn, what type of a structure. There are dashed bonds and there's a wedged bond when you see the three-dimensional structure, and then there are only straight lines. So the straight lines, as I mentioned before many times, that straight lines are for supposed to be in the plane of the page, whereas the wedged bond is the bond that is pointing towards you, towards the viewer, right? And whereas the dashed bond is behind the plane of the page, it's pointing behind. So there are basically three types of bonds that can be shown, and that can show you different connectivities, how they have been connected, right? So let's begin. I will now start making the models and I will show you one by one how to do it. Okay, so just wait. Okay, now so we have I've shown you first this nitrogen molecule that has been connected via this triple bond, that is the two nitrogens having the triple bond between them. Right now I have another compound, the butane. It has got 4 carbon atoms. You can see 1, 2, 3, 4. So we need to have 4 carbons, 1, 2, 3, 4, and of course the bonds to connect them, and the hydrogens that are over there, right? How many hydrogens? Of course, the 10 hydrogens that are here. Okay, so I'm going to build the model to show you how to connect them and how to make a butane molecule. Okay, so I'll start making the butane molecule. Let's start connecting them together. As we know that butane has 4 carbon atoms, right? And yes, 10 hydrogens. Yeah, here it goes. Pretty cool. Wow. Okay, CH3 we have made. Now the next one. Okay, there is CH3, CH2. Well, that's fun. the third carbon. Now it's propane. You can see it's propane, the 3 carbon atoms, the propane. Now let me join again. CH2, CH2, and then of course the third one. The last but not the least, the 4th carbon. Wow, how beautiful it looks. Just see the connectivities. Just see the zigzag shape, which you will not see when you will draw it on the paper, right? So CH3, CH2, CH2, and 1 is left. So let me take it out from my packet. A bond was missing. There it is. So here we go. This is your butane molecule. Just look at here. You have the 4 carbons, and see the zigzag shape of this molecule, right? And now let's attach the hydrogen atoms so that you will simply see a beautiful butane molecule, and you will learn how to construct a butane molecule. I'm simply attaching what? The white ones. These are the hydrogens, as I've explained in my previous video, and I hope you have enjoyed watching. I mean, it's just so fun making such molecular models. Now just look at this beautiful model, right? Just see the shape, how it looks. Oh my God, it's simply amazing, right? So this is simply a butane molecule. Okay, so let me show you how it looks. Okay, now so I can make a zigzag structure for this butane molecule, and how I'm going to make that. So let's see. It could be like that. CH3, then CH2, then again CH2, then again CH3. So this is how the butane molecules zigzag shaped look like, right? These two both, they resemble each other, whereas this one was the straight chain, N-butane, right? It was N-butane, and this is the zigzag form of the butane molecule. So butane has the formula C4H10. Yes, okay. And it is supposed to be very flammable or highly flammable. It is mostly colorless, right? And it's easily it can be, you can liquefy it, you can call it a liquefied gas that can immediately vaporizes at ordinary room temperature. And of course its formula is molecular formula is C4H10. Its boiling point is almost -1 degrees centigrade, whereas its molar mass is 58.12 grams per mole, right? And its IUPAC name is butane, that is Butane, and its melting point is -138 degrees Celsius, right? So this is a little brief introduction of your compound, and I've shown you how to make the molecular model of this your compound, and what would be the shape, zigzag shaped, right? This is the zigzag shape of your molecule, and this is a straight chain, right? So that's it. Okay, so after preparing the nitrogen molecule and after preparing butane, now let's prepare acetaldehyde. Now acetaldehyde is also termed as ethanol, ethanal. It's an aldehyde. It occurs naturally in nature, right? And it can be prepared in any industry, and it can be synthesized easily in the industries, right? So it has got 2 carbon atoms and of course 5 hydrogens with a double bond in it. So let's start preparing acetaldehyde molecule by using the molecular kit. Okay, so this is it, how you are going to prepare it. Okay, so let's start preparing acetaldehyde. Let's connect the two. For that we'll be needing 2 carbon atoms, right? And of course these are the 2 carbon atoms, and yes, 4 hydrogens and an oxygen, beautiful oxygen atom. So let's start preparing them. Oh, please don't go. Okay, CH3, CH3, then CH, then CH, double bond, O. Let's connect the hydrogens together. We are making, okay, so I'm connecting the hydrogens. Okay, so you have a beautiful acetaldehyde molecule. Just look at it. CH3, CH, double bond, O. Wow, it just looks simply amazing. Just look at this beautiful molecule. And the connectivity is how they are connected. So this is how you can prepare an acetaldehyde or an ethanol molecule. It's an, as I just told you, it's an aldehyde, and it's found easily in nature, and it can be synthesized in the industry, right? And it has many other properties also, which I will explain it to you. Let's see the structure first. I will show you the structure first. So this is the beautiful structure, the molecular model of acetaldehyde, right, with the 3 carbon atoms, right, the 2 carbon atoms and 3 hydrogens over here, and of course the second carbon that is attached to a single hydrogen and is bonded to a double bond over here, connecting the oxygen atom, C double bond O, CH3, CH, C double bond O. So this is the formula, and this is the straight chain formula for the compound, which you can see here easily, right? Or as I've just mentioned to you, that it's organic chemical compound, right? And its formula is C2H4O or CH3CHO. You can call it ethanol, okay? And its boiling point is almost 20.2 degrees centigrade, right? Whereas its molar mass is 44.05 grams per mole. Its density is 788 kilograms per meter square. And so this was something very interesting about this compound called acetaldehyde, and this is the beautiful molecule. You can see its shape, right? Its 3-dimensional view, how it looks like. I hope you like it. how I have just constructed this for you just in front of you so that you can see it easily. You can match it with this one, with the structure, right? You can match your compound with the structure, right? So this is simply amazing. You can simply visualize, you can simply see the bondings and the connectivities of this acetaldehyde molecule. Now, after preparing nitrogen molecule, acetaldehyde molecule, and the butane molecule, let's prepare the benzene molecule, right? C6H6, the benzene molecule with alternate double bonds, right? And the delocalization of the bonds is also there. You know, the electrons are constantly moving. So let's prepare our benzene. So now I'm going to prepare a benzene molecule for you people that has the formula C6H6. Right now it has got how many carbon atoms? 1, 2, 3, 4, 5, 6, and having the alternate double bonds with how many hydrogens? 1, 2, 3, 4, 5, 6. C6H6. Now I have the single bonds with me and I have the double bonds with me and the carbon atoms. So let's make the benzene molecule. Okay, now so as I just mentioned, I'm going to make benzene molecule. So let's start preparing. Let's build up our first benzene molecule. Okay. Single bond will be connected here, whereas at this side I need to connect it. So I'll be connecting it via double bond. Well, there it is, and now I will simply join it by a single bond again, of course by a carbon atom, yes. Now again a double bond. As it has got the alternate double bonds, the benzene molecule, the benzene ring, okay, C6H6. So you need to connect it. Second alternate double bond. Wow, it looks so beautiful. And then by a single bond. Again a carbon atom, and now again a double bond, as it has got alternate double bonds. So you can see the first bond, double bond, and then a single bond, and then again a second alternate double bond, then again a single bond, then again the third alternate double bond. There it goes. Wow. Now let's start attaching the hydrogens. For that you need to attach the bonds, the single bonds, okay? Oh wow, such a beautiful molecule. It's simply amazing. Let's start, connecting the hydrogens so that you have that complete amazing look of the benzene molecule C6H6. There it goes. Yes. There it goes. 1, 2, 3, 4, 5, 6. Wow. Amazing. You can see the molecule. How it looks. Simply beautiful and perfect. You can see all the alternate double bondings. You can match the structure now with the original molecule. Now this is the structure of the benzene molecule we have just prepared, and you can compare it with the structure here, right, with all the carbons and 6 carbons and hydrogens that are in a planar form. So I've just prepared this beautiful benzene molecule for you people. You can see the alternate double bonds, right? And it has got the formula C6H6, and it is composed of 6 carbon atoms, right? Joined in a planar, of course, ring structure, ring-like structure, and with 1 hydrogen atom attached to each carbon atom, right? These white ones are the hydrogen atoms. And it contains only carbon and hydrogen atoms, so it is can be called as a hydrocarbon. Its now formula is C6H6, right, which I just mentioned it here, and its molar mass is 78.11 grams per mole, and its boiling point is almost 80.1 degrees Celsius. Its IUPAC name is simply benzene, right? Whereas its density is 876 kilogram per meter square. It is mostly soluble in acetic acid, in acetones, in chloroforms, in carbon tetrachlorides, and alcohols, and in diethyl ethers. So this was your beautiful molecule, a benzene molecule, right? And this is the structure, how you can build a benzene molecule by using the ball and stick model. Now these are the ball and stick models. They are easily to construct. So today we have now prepared how many molecules we have prepared? 4 molecules, right? So this is the second one. This is butane, this is your acetaldehyde, and of course the nitrogen molecule which you have prepared earlier. So this was it. These are the beautiful models, the 3D models you can see. Molecule, as it has got the alternate double bonds, so it's more attractive, you know, because here you can see the bondings easily. And of course this molecule, the acetaldehyde with an oxygen atom. So this is the butane molecule, in which I've shown you the zigzag shape of the butane molecule, right? See how it looks like. And here also you can see the different, you can see the angles, and you can see I've not explained that, the chemistry of all these things. I just wanted you to know how to build a ball and stick model of different organic compounds, right? So these 4 compounds today we have prepared and I've shown you, and I hope you have enjoyed watching these molecules, how to build them up and how to study them, how to see the connectivities, how they are connected, right? And look at this beautiful oxygen atom. I am so much in love with this red color. Looks so beautiful. Wow. So that's it for today. I hope you find this video interesting and you will learn now how to make different molecular models. So today I have tried my best to make and to show you different models, how to make the butane molecule, and then of course the benzene. You can see the benzene C6H6. It's beautiful with all these 3 alternate double bonds in it, and the nitrogen molecule having a triple bond between it, right? And of course an acetaldehyde and ethanol molecule. So these 4 compounds we have prepared, and I have shown you how to build them by using the ball and stick model. These are all the ball and stick model. These are not the space filling models. The main difference between space filling and ball and stick model is that in the space filling models you will not be able to see how they are, the geometry. You will not be able to see the geometry, how they are connected. Their connectivity is not visible in the space filling models, whereas in these you can simply easily see how they are connected. So I hope you like my video. Share among with your friends. Thank you. So this was all for today. I hope you like my video. I hope you have followed how you are going to prepare these different compounds, how you will prepare them, right? This one, this one, this one, and of course this one, the beautiful one that has got the red atom in it, right? My favorite, the oxygen atom, and the nitrogens, these beautiful blues. Blue is my favorite color. So I like making all these models for you. So I hope you like this, because I am making the most important aspect of making this video is that I wanted you to visualize how these atoms are connected, and there of course their geometry between them, and of course how to build them by using different bonds, how you are going to connect different bonds together. In this way you have learned how the double and the single bonds are connected to make a benzene structure, a cyclic structure, right? Though it is planar, but it's cyclic structure. So you learned a lot. You learned how to attach an oxygen atom via a single, these double bonds, and of course how these connectivities are there, single bonds are there. So I hope you like my video. I hope you will share with your friends. You will learn. Instead of sharing, it's good if you start learning and you will start making these molecular models on the pages, on papers first. So first draw them on the papers as I have drawn, right? Just draw them like that so that you will have enough knowledge how to draw them, and then start making with the help of these molecular models. If you have access of these models, you can use them and you can make number of molecular models. There are hundreds, millions of compounds which you can easily make, and you can easily understand the geometry of your compounds. So in my next video, I will hopefully will start with something more interesting and related to the 3D structures of different compounds, and most probably let's see what's coming up in my mind, because the topics and the subject I'm interested in, I only select those topics for you people which I find the most interesting and most easy to follow and easy to memorize, because memorizing these things is very essential. Because if you are a pure organic chemistry, this field is very interesting. This stereochemistry is very interesting to learn how to visualize these compounds while they are rotating in space. So I hope you will learn it, and you will learn a lot from this video. Thank you so much. See you next time with something new, something more interesting, more absorbing, and more exciting. Till next time, so I'm now signing off. So bye bye. Thank you.